to my YouTube channel. So in today's video we are going to continue from where we left off in the previous video. So we are still on applications of difference of two squares, and in today's video we'll be looking at how to apply difference of two squares to solve equations. Okay, so we'll be making use of this formula once more, and we'll be going through these examples to help us understand how we can use difference of two squares to solve certain equations. Okay, so the first example is x squared minus 49 equals 0. So for this particular example, we are going to apply the principle of difference of two squares. Okay, so we can write 49 as 7 squared. Okay, since we already know how the difference of two squares work, after we get the two squares, we can just recall our formula and then break down the two squares as this. So we can have x plus 7 in one bracket and x minus 7 in another bracket, and this will be equal to 0. And when we get it like this, we just take each expression in the bracket and equate it to 0. So for x plus 7 equals 0, we are going to get x as negative 7. And for x minus 7 equals 0, we are going to get x equals 7. Hence, the two values of x will be negative 7 and 7. So you can rewrite it as the first part where you have x equals negative 7 and x equals 7, or you can combine them and write your two values as x equals plus or minus 7. Okay. Now, keep in mind that you could have also solved this equation by using the square root method. Okay, so we just send the 49 to the other side of the equation, and that would have given you x squared equals 49. Then you take the square root on both sides. That would have given you the same answer. Just that we went through these steps because we are applying difference of two squares. Okay, so that will be all for this example. The second example is x squared minus 25 equals 0. So pretty much similar to the previous example. Recall our formula, break them down, equate each expression to 0, and we arrive at x equals negative 5 and 5, or you can combine them. Again, you could have solved this with the square root method. You'd have gotten the same answers. Okay. Now keep in mind that we are looking for real values, right? And as far as the real values or real numbers system is concerned, we are only dealing with real numbers basically. Apart from real numbers, we wouldn't be interested in any other numbers. So we will be taking complex numbers out of this particular lecture or video. Okay. The third example, we have 81 minus y to the fourth power equals 0, and we want to apply difference of two squares to solve it. Again, for this particular question, you could have sent the y to the fourth power to the other side, and then you take the fourth root of 81 on both sides. You get your answers. Okay, you get your real values or your real answers. But we want to apply difference of two squares. So first of all, we make sure we get the two squares we are looking for. Okay, so we can write 81 as 9 squared, and we can write y to the fourth power as y squared, then the whole of the y squared again. Okay, so we end up having this equation on the second line, and from there we can recall our formula, and then we break the equation down. So we have 9 plus y squared in one bracket and 9 minus y squared in the second bracket, and that whole expression being equal to 0. So pretty much the same thing, right? You can take each expression in the bracket and equate it to 0. But for the first expression, which is 9 plus y squared equals 0, we wouldn't really get any real solution, right? And the reason why we wouldn't get any real solution is that even if you apply the square root method, you will usually end up with an equation like y squared equals -9, right? And we don't have square root of negative numbers in the real number system. So that is why I said we are focusing on just real numbers. If we were looking for all solutions for the equations we are dealing with, then we would have probably gone ahead to square root both sides, right? That would have given us a complex number. But we are looking for just real solutions. So as far as 9 plus y squared equals 0 is concerned, there's no real solution. Okay, so we will skip that and then move on to the next expression. Also, 9 plus y squared is no difference, so you can't really apply difference of two squares. Even though 9 is a square, y squared is also a square, but it's no difference, so you can't apply that principle over here. Okay, so we cannot use the formula we know of. Right? Okay, so with that being said, we will move on to the next expression, which is 9 minus y squared equals 0. And for that, we can apply difference of two squares. Okay, so we just rewrite them as difference of two squares. We split them and we equate each expression in the bracket to 0. And we eventually end up with -3 and +3 as the values of y. So that will be all for this particular example. The fourth example is 36a cubed minus 100a equals 0. You can pause the video and try this particular question. But basically, what we are going to do over here is that because we want to apply difference of two squares to make the work easier for us, we will have to make sure that we have difference of two squares, right? So the first thing we are going to do is to try and then factor out the common term, which in this case it's a. So we factorize a out of the expression on the left hand side, and that will give us a with 36a squared minus 100 in the brackets being equal to 0. Okay, now we can focus on the terms in the brackets or the expression in the brackets and make sure we have difference of two squares. Okay, so by applying the principle, we will rewrite them as 6 squared a squared minus 10 squared, right? We now have difference of two squares in the bracket, so we can apply our formula. So we recall the formula and then we apply it. So we are just using that for the term in the square brackets. Okay, so our equation will now be a outside, then 6a plus 10 in one bracket, 6a minus 10 in another bracket being equal to 0. Then you just pick each single term equated to 0. So you pick a first, a will be 0. You pick 6a plus 10, a will eventually be -5 on 3. And then you pick 6 minus 10 equals 0. You end up at a being 5/3. So we have three values of a for this particular question, which is 0, -5 on 3, and +5 on 3. And that will be our answers for the fourth equation. Okay, so always do go to confirm your answer after solving an equation. This doesn't apply to just this video, but to any other equation you saw, right? So by inputting your value, right, the answers you've gotten into the original equation to make sure that your answer satisfies the original equation is how you confirm your answer. Okay, and I'll leave this for you to try and leave your answers in the comment section. Yeah, I think that will be all for today, and thanks for watching again. Subscribe for more, and I'll see you in my next video. So we'll meet again. Peace be unto you. Goodbye.